Welcome back to second lecture on Class 10 Science Chapter 10 Light. In this lecture, we shall discuss the image formation by spherical mirrors using ray diagrams. Let's get started by understanding what are ray diagrams and how to make them. So ray diagrams are a method of locating the position of image. Now there are few rules for making the ray diagrams. So let's understand these rules first for concave mirror and then for convex mirror. So now let's understand the rules for making ray diagram for a concave mirror. So here we are having a concave mirror and it is a curved inwards mirror and its outside has been silvered. So we have put oblique lines, small oblique lines on the outside of the mirror to show that it is a concave mirror. Now here we have the various parts of the mirror. This is the pole of the mirror, this is the center of curvature, and here we have the focus, and this is the principal axis. This green line is the principal axis. And now while making the ray diagram, you must be ensure that the distance between the pole and the center of curvature is equal to the distance between the focus and the pole. So for this you can use a scale. So I have used a scale and have ensured that the distance between the point C and point F is same as the distance between point C, point F and point P. And if you don't do that, then you might get some wrong ray diagram. So you must ensure that. So this is the base diagram for our ray diagram. And now we will draw the various incident and reflected rays for the various rules. So let's start with the rule 1 for concave mirror. So the rule 1 says that if the incident ray is parallel to principal axis, then reflected ray passes through the focus. So here let's take a point, and from this point we will make a incident ray, a ray which falls on this mirror and is parallel to this principal axis. So this is the principal axis and this incident ray is parallel to the principal axis. And now when this ray will get reflected, then the rule says that this ray will pass through the focus. So this means that if the incident ray is parallel to the principal axis, then the reflected ray will pass through the focus. This is a rule. Now let's discuss the second rule. So the second rule is just the opposite of the rule 1. It says that if the incident ray passes through the focus, then the reflected ray is parallel to the principal axis. So here I have drawn a ray that is passing through the focus. So the reflected ray is parallel to the principal axis. This is the second rule. Now let's discuss our third rule. So the third rule says that if we draw an incident ray passing through the center of curvature, then it passes through the center of curvature on getting reflected. So if the incident ray is passing through the center of curvature, then when it will get reflected, then the reflected ray will also pass through the center of curvature. So the reflected ray will trace the same path and pass through the center of curvature. And the fourth and last rule for concave mirror is that if the incident ray strikes the pole at an angle, then the reflected ray makes the same angle with the principal axis. So here incident ray is falling on the pole at some angle. The reflected ray will go back at the same angle. So if consider that this angle is 30 degree, so the reflected ray will also make the same angle, that is 30 degree. And this is because according to the laws of reflection, it says that angle I is equal to angle R. So therefore, if the incident ray is falling at 30 degree angle, so it will get reflected at 30 degree angle. This is the rule 4. So now, after learning about the various rules for making the ray diagrams, we now know how to make a ray diagram for a concave mirror. Now let's understand how can we make images. So we will take different scenarios and try to make images. So in the first case, we will take the object to be beyond the center of curvature. So here we are having a concave mirror and we will place the object beyond the center of curvature. So here is the center of curvature and let's place it beyond the center of curvature. So here I am taking an object AB and have placed it beyond the center of curvature. And now what we have to do is that we have to make an image. Now to make an image, the rule is that we need to make any two rays from the object, and where these two rays meet, at that point the image will be formed. So basically if we draw two rays from this object, then where the both of the reflected rays will meet, that point is where the image will be formed. And how do we make the rays? For making the rays, we just have to take any two rules. So we learned about four rules in the previous just now, and we have to use any two rules to make two rays, and where they will intersect, then the image will be formed at that point. So let's use the first and second rule. The first rule says that if the incident ray is parallel to the principal axis, then the reflected ray passes through the focus. So here I have drawn the incident ray parallel to the principal axis and the reflected ray is passing through the focus. This is our ray 1. Now let's draw another ray. So our ray 2, we are drawing a ray passing through the focus, and it will be parallel to the principal axis after reflection. So here you can see that it is parallel to the principal axis after reflection. So here we have both the rays, and can you tell me where they are meeting? So they are meeting at this point, and you can see that this point is between the center of curvature and the focus. So we can say that if the object is placed beyond the center of curvature, then the image is formed between the center of curvature and the focus. And now you may observe that. So first let's fill this. So object is beyond C. So the position of image will be between center of curvature and focus. And now you may have observed that this image formed is slightly smaller than the main object. So object AB is the object, and let's name the image as B dash A dash. This will be our image. Now you may observe that this image is inverted. This is because both of the rays are coming from the A point and they are meeting below the principal axis. That's why this image formed is inverted. So in nature we can say that the image is inverted, and also you can observe that both of these rays are actually meeting at a point. So actually meeting rays means that a real image is formed. That's why in nature we will write that image is inverted and image is real. And in size, you can observe that this image is slightly smaller than the object. So we can write diminished, slightly diminished. In the size of object. So in this way we are able to fill the first column, that is, if the object is beyond C, then position of image is between C and F, size of image is slightly diminished, and nature of image is inverted and real. And we have proved everything using this diagram, and there is no thing to remember. Now let's discuss the second scenario in which the object is placed at C. So at the center of curvature the object is placed. Here we are making the object AB. And now we will again do the same thing. We will apply two rules out of those four rules. Get the position of image, and on basis of the position we will get the size and nature of the image. So now again we will use the first and second rule only. The first rule, the incident ray is parallel to the principal axis. Reflected ray passes to the focus. The second rule, incident ray passes through the focus, reflected ray is parallel to the principal axis. Now applying both the rules, we can get that the intersection point is this. So you can see that both of these images are intersecting at C. So at the point C, both of these rays are intersecting. So the image, that is B dash A dash, is formed on the point C at the center of curvature. So now let's fill the table. If the position of object is at the center of curvature, then the image is also formed at the center of curvature. The size of the image, you can see that they are equal in size. So you can write equal. And nature of image, again you can see that this image is inverted, B is above and A is down. And again, as the rays are actually meeting, the image is real. So here we have filled the second case also. So in the third case, we are having the object between the center of curvature and the focus. So here the object is between the center of curvature and focus. Here we have AB object. And now let's draw the rays. So the first ray, again applying the first rule, incident ray parallel to principal axis, reflected ray passes through focus. Second rule, incident ray passes through focus, reflected ray parallel to principal axis. So here you can observe that this time both the rays are meeting beyond the center of curvature. So here is the position where the object, that is where the image, that is B dash A dash, will be formed. So AB is the object and A dash B dash is the image. And again let's fill the table. The object is between C and F. The image is formed beyond C. And the size of image, this time you can observe that the object is very small but the image is highly big. So the image is magnified, that is larger in size. And nature of image, again the rays are actually meeting, image is real, and again the image is inverted as it is formed below the principal axis. Now in the next case, the object is placed at the focus. So at the focus point, we are placing the object. Now position of image. So again we will use the two rules. Applying the first rule, incident ray is parallel to the principal axis, reflected ray will pass through the focus. And now let's apply the second rule. So it says that if the incident ray is passing through the focus, then reflected ray will be parallel to the principal axis. But now you can see that the image is being formed at the focus itself. So this means that we cannot use the second rule, because now the incident ray cannot pass through the focus as the image is only being formed at the focus. So this means that rule 2 cannot be applied in this case. So that's why we will have to use some other rule. So let's see which rule we will use. We can use either the third rule, that is if the incident ray is passing through the center of curvature, then it will get reflected along the center of curvature, or the fourth rule, that is if the incident ray is passing through the pole, then the reflected ray will also get passed through the pole at the same angle. So I think that we should use the fourth rule, but you can also use the third rule and then also you will get the same answer. So here I am making the incident ray fall at the pole at some angle, and at the same angle the reflected ray will get reflected. So consider this angle to be x. So this reflected ray is also making the same angle with the principal axis. So now here you can see that both of these lines are almost parallel to each other. So both of the reflected rays are almost parallel to each other. So they are not appearing to meet. But if we keep on extending them, then at some point they will meet. So at some point both of these rays will meet. So we can say that the position of image will be at infinity. So at some point both of these images will meet because the lines are almost parallel. And size of image, as they will meet in the at infinity at very large along a very large time, so that's why the image will be highly magnified. It will be very big in size. And again the nature of image will be real and inverted. So this was the exception in which the images are not meeting, but they will meet at infinity and the image will be highly magnified, real and inverted. So now let's study the next case. In this case, the object is placed between the focus and the pole. So between the focus and the pole, the object AB is placed. And now again we will use two rules. The first rule, incident ray is parallel to the principal axis. The reflected ray will pass through the focus. But again in this case, the second rule cannot be applied. This is because the image is being formed ahead of the focus. So how can the incident ray pass through the focus? So that's why we cannot apply the rule 2. So let's apply the rule 4. Incident ray strikes the pole at an angle. Reflected ray makes the same angle. So now this time you can see that this is a little wrong. Okay. So now this time you can see that both of these rays are not meeting if we keep on extending them because they are diverging from here. They will go like this. But if we extend them backwards, then they meet. Then they may meet. So here, on extending both of the rays backwards, they have met. So here the image will be formed. A dash, B dash. So now let's fill the chart. So the object is between pole and focus and the image is being formed behind the mirror. So this is another exception in which the object is being formed behind the mirror. And again the image is much bigger than the object. So the image is magnified, larger. But this time you can see that the rays are not actually meeting. We have extended them backward behind the mirror. So that's why you can see that the rays are appearing to meet but they are not actually meeting. So that's why the image will be virtual. As the rays are not actually meeting, they are just appearing to meet. And you can see that this time the image is erect. That means the image is upright. This time the image is not inverted. So it is formed above the principal axis. That's why image will be erect. That is, image will be upright. Now let's discuss the last case in which the object is placed at infinity. So to represent that the object is placed at infinity, what we will do is that we will rub a part of the principal axis and make a dotted line. This represents that the object is placed at infinity. So now let's apply the rules. In this time we will apply the rule 1 2 times. So we will apply the rule 1 once from point A and once from point B, and where both the rays will meet, at that point the image will be formed. So here applying rule 1 for point A and rule 1 for point B. So you can see that both of these rays are meeting at the focus point. So this means that the image will be formed at the focus point. But you can see that this time the image is very small in size. It is point sized. So it will be very small. Now let's fill the table. The object is at infinity, the image is formed at the focus, and size of image is point sized, which means it is very small, and the nature of image, again it will be real as the rays are actually meeting, and it will be inverted. Now, after learning all about concave mirrors, let's learn the rules for drawing the ray diagrams for convex mirror. So as you know that a convex mirror is a curved outside type of mirror in which the reflecting surface is outside and the inner surface is silvered. And also in the convex mirror, the focus and the center of curvature are behind the mirror. So here this is the mirror, and behind the mirror we have the focus as well as the center of curvature. And this green line is the principal axis. Now let's study the rules. So the rule 1 says that if the incident ray is parallel to the principal axis, then the reflected ray appears to pass from the focus. So, the reflected ray will appear to pass from the focus. It is not actually passing through the focus, but it will appear that it is originating from the focus. So, here you can see that this dotted line represents that it is passing from the focus, but it is appearing to pass from the focus. It is not actually passing from the focus. So, if the incident ray is parallel to the principal axis, then the reflected ray appears to pass from the focus. Now, the second rule for convex mirror says that if the incident ray is directed towards the center of curvature of the mirror, then the reflected ray appears to pass through the center of curvature. So here I am making an incident ray directed towards the center of curvature. So when extended, it will pass through the center of curvature. So the reflected ray will also trace the same path, and the reflected ray will also appear to pass through the center of curvature. So when it is directed towards the center of curvature, the reflected ray will follow the same path and appear to pass from the center of curvature. Now the third rule says that if the incident ray is directed towards the focus, then the reflected ray is parallel to the principal axis. So here I am making an incident ray which is directed towards the focus. On extending, it will pass through the focus, and the reflected ray is parallel to the principal axis. The reflected ray will be like this. It will be parallel to the principal axis. Now, the fourth and last rule says that if the incident ray strikes the pole at some angle, then the reflected ray makes the same angle with the principal axis. So here the incident ray is coming at an angle, and the reflected ray will be reflected at the same angle. So consider this angle is x. So the reflected ray, the angle between the reflected ray and principal axis will also be x. So if the incident ray strikes the pole at an angle, the reflected ray makes the same angle with the principal axis. So almost all these four rules are similar to the rules of the concave mirror. So now let's understand image formation by convex mirrors after learning all the rules to draw the ray diagrams. So here the first case we will take is that the object is between the pole and infinity. So here this point I have taken as infinity and I have represented it by using a dotted line. This is green line is our principal axis. Here is our pole, focus and center of curvature behind the mirror. So now let's draw the object. So the object is between the pole and infinity. So I have taken the object to be at this point. And now we will use any two rules to draw the two rays coming from this object, and then where they will intersect, at that point image will be formed, and after that we will get the properties of image. So let's use the first rule, which says that if we draw line, incident ray, is parallel to the principal axis, then the reflected ray appears to pass through the focus. So here a reflected ray will appear to pass through the focus. This will be a reflected ray. And let's use this third rule, which says that if the incident ray is directed towards the focus, so it will pass through the focus, then the reflected ray is parallel to the principal axis. So here by using both of these rules, we have got the two reflected rays. And now when you will extend this reflected ray back, then you will find that both of these reflected rays meet at this point. So both of these rays will meet at this point. And here the image will be formed. That is A dash, B dash. And here you can see that both of these rays are meeting at a point between the pole and the focus. So from here we can say that the position of image will be between the pole and focus, between P and F. And similarly, so from here we can say that the position of image will be between the pole and the focus. So between P and F. And similarly, you can see that the size of image is smaller than the size of object. Size of object is this and size of image is smaller. So that's why we can say that the image is diminished. It is smaller in size. Diminished. And now we have the nature of image. So you can see that this image is erect. And also you can see that this image is formed not by the actual meeting of rays. So the rays are not actually meeting, they are meeting behind the mirror and they are appearing to meet. They are not actually meeting, they are appearing to meet. And such an image is known as virtual image. And one thing you can add in the position of image is that the position of image will be behind the mirror. As you can see that the image is being formed behind the mirror. So here you can see that object is between pole and infinity, position of image is between pole and focus, behind the mirror, size of image is diminished, and nature of image is erect and virtual. Now let's discuss the second case, which is the object is placed at infinity. So at the infinity point, let me rub this. So at the infinity point, the object will be placed. We have AB object. And now let's draw the rays. So all the rays which we draw parallel to the principal axis, all of them will meet at the focus. So all of them will appear to meet at the focus. All of the reflected rays will appear that they are meeting at the focus. So this means that the meeting point of all the rays is at the focus. This means that the image will be formed at the focus. And the size of image, if you observe, is very small. It is point sized. And the nature of image will again be virtual, as the rays are appearing to meet. And also it will be erect. Now one thing you can remember is that whenever a real image is formed, then it is inverted, And whenever a virtual image is formed, then always it is erect. So even if it is very point sized and you are not able to observe it by your eyes, then if it is virtual, then always it will be erect. And again, the position of image here will be at the focus behind the mirror. The virtual images are found behind the mirror. Now let's understand the uses of concave and convex mirrors. First, let's understand the uses of concave mirrors. First, concave mirrors are used in searchlight, torches and headlights of vehicles. This is because this is done to get a powerful beam of light. So, we have studied earlier in image formation that when we place the light source at the focus, we get the reflected ray which travels till infinity. So, this property is used to get a powerful beam of light. Second, in shaving mirrors and dentist mirrors. So, this is done in order to get the larger image of the face and the teeth, so that the dentist is easily able to see all our teeth. And third, the concave mirrors are used in solar furnaces. This is done so that large concave mirrors are used to concentrate the sunlight to produce heat in solar furnaces. So a property of the concave mirrors is that they give a real image, and real image can be caught on screen. And in this way, the large concave mirrors are used to concentrate the sunlight to produce the heat in solar furnaces. Now let's understand the uses of convex mirrors. First, they are used in rear view mirrors of vehicles. This is to provide a wide field of view and help the driver to see the traffic behind him. Second, as a reflector in street lamps. So this was all for today. In the next lecture, we shall discuss more about reflection of light and formulas. Thank you.